Okay, so in this video, we're going to be looking at reducing combinations of trig functions with inverse trig functions inside of them. Now, this is a situation that comes up all too frequently with some of my students in my Calc 2 class trying to do trig substitution problems. And you can't leave things like this. And so we're going to walk through some examples of how to convert these into algebraic expressions so that we don't have these trig functions with these embedded inverse trig functions. Now, obviously, if you have, for example, sine of inverse sine, assuming that x is in the domain of the inverse sine, then the sine and the inverse sine will cancel. But when you have different combinations of trig functions, then you have to go about this in a slightly different way. And so we're going to create a triangle that we can then work with. We'll create our right triangle. And I like my right triangle oriented differently, so we're going to turn that around. And let's make this a little bit bigger. And what I'm going to do is I'm going to insert a text box in here. We're going to call this theta. And let's take out the fill for my shape. No fill. So we're going to call this angle theta. And we're going to put in some text box for some additional variables. Now, tangent, recall that tangent is opposite over adjacent. So let's think about our original tangent function here. We're basically saying that we have an angle theta, which is equal to the inverse tangent of x. So this is another way of saying that tangent of theta is equal to x, or specifically x over 1. Now, what that's going to do for us is that's going to, let's get rid of this border here as well, if I possibly can. No outline, there we go. So opposite over adjacent. So I'm going to grab my text box and I'm going to copy it. Opposite is x and adjacent is 1. Now, what does that tell me about what the hypotenuse looks like? Let's stick this over here. The hypotenuse, the square of the A side, the square of the B side, put it all into the square root. So this is going to be the square root of x squared plus 1. So that's using this inverse trig function on the inside of my expression. Here's my angle theta. That's what it's the inverse tangent of x is standing in for. And a inverse tangent of x, theta, is an angle. The tangent is x over 1. I put in my opposite. I put in my adjacent. I've solved for my missing side, which is my hypotenuse in this case. And now I'm going to find the sine of this angle. Sine of theta, based on this triangle, is now going to be opposite over hypotenuse. So x over the square root of x squared plus 1. Now, all of these trig, inverse trig combinations have to be solved this way, especially with the inverse trig on the inside. You cannot leave them like this. And the same thing is going to go for if you've got double angle formulas, you may need to apply an identity in order to simplify them. You're not going to be able to just do them, just leave them that way. Let's do one additional example. So let's say I want to do secant of inverse sine of, we'll do 2x just to make it a little bit different. Now remember, what this sine 2x is telling me is that this is equal to theta. And that means that sine of theta is equal to 2x, or 2x over 1. Now, rather than reconstruct this whole thing, I'm just going to copy this and we're going to modify it. Now, again, here's theta. Now we're doing sine. So sine is opposite over hypotenuse. The hypotenuse in this case is the 1, not down here. Now, what is the missing side? Well, it's going to be 1 minus the square of 1 minus the square of the other side, and then we take the square root. So again, we're solving using the Pythagorean theorem. 2x squared, 2x quantity squared is 4x squared. And so now this becomes my opposite side, my adjacent side, opposite, hypotenuse, adjacent. And so now what is the secant of this angle? The secant of this angle is now going to be what is the secant? It's the reciprocal of cosine, right? So cosine is adjacent over hypotenuse. So this is going to be 1 over the hypotenuse. So anytime you're trying to do this, you always have to set up your triangle. You have to get your angle theta in terms of a single theta. It can't be 2 theta or something like that. You have to use your identities and then use them to solve for the algebraic expression that is equivalent to these trig inverse trig combinations.